For this week's experiment, we're gonna need 2 plastic cups and they'll be filled halfway with water. And as you can see, I've added paint to each of these cups to give the water some color. Food coloring will be better, but since I don't have any food coloring, paint is okay also, as long as you can see the water clearly. And now here, I've got a small cup of oil and I'm gonna pour it in. I'm gonna pour some in this cup too. And as you can see, if we wait a while, the oil will form a small layer above the water. The orange one has pretty much turned into 2 layers already. There's still a bubble on the green one, so we're gonna have to wait a while. Yep, okay, so now both of these have a nice thin layer of oil on top. So for the next step of the experiment, we're gonna have our cups of colored water and oil. And in one of those cups, we're gonna add a bit of dish soap. And for this experiment, I'm just gonna add it in the green cup. Okay, so you can see that the dish soap has sank to the bottom in a little pile like that. And as you watch, even though there's still a bit of soap at the top, it's slowly dripping down to form a big pile at the bottom of the green cup. And now I'm going to invite my little lab assistant to help me out with the next experiment. The next step of the experiment. So now we're going to start by mixing up the orange cup. And remember, the orange cup is the one with only oil and water and no soap.
And food coloring.
And food coloring. So we mix it up. Do you think that looks good?
Yeah.
Okay, green one now. Mix up the green one. Make sure to mix up the bottom too, the soap.
Yeah.
Okay, now keep mixing until you think everything looks like a big mix-up bunch. Good, the green one looks good to me. What about you?
Good.
Okay, now mix the orange one a bit more. Okay, you can stop now. So as you watch, so the orange one, you can see that even though we mix it up pretty nicely, in the end, as we wait a while, the oil will form its layer at the top again, almost like it wants to return to its original position at the top of the water. See, it's back at the top again. And after a while, the bubbles will pop and it'll just be a nice thin layer like in the beginning. But let's look at the green one now. If we let it settle for a while, you can see that the soap, the oil, and the colored water are all mixed together. So unlike the orange one, in this one, the oil isn't going back to the top. And I think it might look better if we mix it a bit more thoroughly. So you can see that now it's just soap bubbles at the top and a mix of oil, water, soap, paint, whatever, a bunch of that at the bottom. So to explain what happened when we mixed oil with water and in the green cup, oil with water and soap, let's look at a sample of our cup. So right now in here we have water. And now water, as you know, is H2O, so 2 hydrogens and 1 oxygen. And since oxygen has more electronegativity than hydrogen, which means that it attracts more electrons, in the water, the oxygens will have a partially negative charge, and the hydrogens will have a partially positive charge. Now that's the same for all the other water molecules. All the oxygens in the water molecules have partially negative charges, and all the hydrogen have partially positive charges. So, as you may already know, positive and negative, they attract each other. So the positive hydrogens and the negative oxygens, they're attracted to each other, forming this kind of bond that makes all the water molecules cluster together in their little cluster. And then they're just happily in their little pile of water molecules when suddenly we drop in a few fat and oil molecules. So oil molecules, well, let's say these oil molecules just drop in, and the water, they form tight bonds already, so they don't really let the oil in. So the oil stays at the top instead of being allowed into the water. It's like at a school when all the friends have gotten into little groups of friends, close friends already, and a new kid comes. Well, the new kid is going to have trouble getting into one of those groups. Same with water. The water is close already, so the oil gets left out and they stay at the top. So what about when the soap molecules come? Well, when the soap molecules come, soap has a kind of straight-ish shape, the soap molecule, and they have hydrogens on the sides and carbon in the middle. And even though this part is nonpolar, we have some molecules and atoms at the tip that's polar. And even though this whole big part is nonpolar, this tiny part is polar. So we have these soap molecules that we dump into this oil and water solution. And what happens is that the soap surrounds the oil molecules. So let's say each soap molecule is aligned with a dot at the top. So the dot represents the polar part and the line represents the nonpolar part. So what happens is, say there's an oil molecule here. The soap will surround it with the polar parts facing out and the nonpolar parts attached to the oil. Something like that. And what happens is that the oil gets kind of surrounded by a layer of soap molecules. Now the water, even though it doesn't let the oil in, since the oil is nonpolar, it'll let the soap in because what's pointing out is all polar, right? The parts that are pointing out of the little blob are all polar. So the water will let them into their little cluster, which is why that after we mix some soap into the green cup and we mix it up, the water and the oil and the soap all mixed together instead of in the orange cup where the oil and the water separated themselves back out even after we mixed it several times. So for the next experiment, we're gonna need a bowl with water in it, around half a bowl of water, and we're also gonna need a lightweight needle. And now first, we're gonna try to balance the needle and make it float on top of the water. As you can see, this one sank. Let me get it out and try again. Nope, it sank again. So we're gonna have to try some other way to get the needle to float on the water. To get the needle to float, we're gonna use a piece of toilet paper. So first we're gonna carefully put that toilet paper in the water. And now we're gonna take the needle and balance it on top of the toilet paper. Okay, as you can see, the needle is now floating. You can carefully take the toilet paper away. And the needle is still floating. Okay, so now we're gonna put a drop of oil into the water as far away from the needle as possible. Okay, let's try that again with a bigger drop of oil, since nothing is happening right now. So now to do this experiment again, I've changed the water, and we're gonna use another piece of toilet paper like before. And we're gonna float our needle on top of it. Nope, the needle sank. Okay, let's try again. Okay, so toilet paper in the water. And now put the needle on the part of the paper that floats. No? Okay. I'm gonna have to try it again. Science is like this. You have to try over and over again until you get it. Okay, so now that I've got the needle to float again, we're gonna put a few drops of oil into the water. And as you can see, the needle kind of floated away from the oil a bit when we dropped the oil in. So now for the next step, we're gonna put a few drops of soap, a few drops of dish soap, as far away from the needle as possible. Okay, and the needle kind of flew away from the soap towards the side of the bowl for a second, and then it kind of bounced back, probably because it hit the bowl and had to bounce. Also, when the needle hit the side of the bowl, it sank. Instead of floating, it hit the side of the bowl and it sank down to the bottom of the bowl. So now we're gonna clean the bowl and we're gonna add some pepper into the new bowl of water. Okay, that's enough. So now we have pepper in our bowl. So now that we have the pepper in the bowl, we're gonna pour a drop of oil into the center of the pepper and see what happens. Okay, so as you can see, nothing much happened to the pepper, but the space around the oil droplets, the tiny bubbles of oil, are pepper free. So the pepper kind of goes away from the drop of oil, I guess. And now we're gonna do the same thing, except with our dish soap. We're gonna pour a drop of dish soap into the center of the pepper and see what happens. Whoa. So as you can see, the moment the soap went into the water, all the pepper kind of flew away from the soap onto the side. And now they're all condensed at the side. I wonder what will happen if I drop another drop of dish soap into the middle of the pepper. Ooh, so it now floats away from that space where I dropped the soap. But it wasn't as dramatic as the first time. Okay, so for the next experiment, we're gonna use milk you're supposed to use a drop of food coloring on the milk, but since I don't have any, I used some red wine instead. And you're also going to need a cotton swab. So first, you're going to dip the dry end of the swab into the middle of the food coloring and see what happens. Okay, so it stuck to the swab for a second and then it floated away a bit, but nothing really happened. So now we're going to take the other end of the swab and put some soap on it. Okay, I think that might be enough. And now we're going to put that end, the soapy end, into the food coloring. Okay, so the red wine only kind of floated away from the soap, but nothing really happened. Not much, it only floated away. Now for the last experiment, we're gonna see how many drops of water we can fit on a penny. Okay, so that was how much water we could fit in a penny before the water overflowed. Let's try that again, since I think I can fit more drops on the penny if I balance the water a bit more.